Hello everyone. On this video we will be looking at higher order derivatives. Okay, so let's say that f of x is your function. Okay, we know that f prime of x, which is the derivative with respect to x of your f of x, is your first derivative. Okay, we know that when you put two slash marks, that's your second derivative of your function, which is just the derivative of your first derivative. Derivative of f with respect to x, which is this one here. And that equals your notation for your second derivative. Okay, so that's your second derivative. Okay, now your third derivative will have the three hash marks, which is the derivative of your second derivative. Clean that up a little bit. Okay, so the derivative of your second derivative is your third derivative. Third derivative. Okay, now anything higher than the third derivative will not have more slash marks in most cases. Usually they'll just have the actual numerical value. So that's the fourth derivative of x, which is just the derivative of the third derivative. Oh, there we go. Which becomes your fourth derivative. Okay, now from there, it just keeps going and going and going to as far as you want. So for your, let's say if you want to find your 50th derivative. Your 50th derivative of x would equal the derivative of your 49th derivative. Which would give you the notation of your 50th derivative. Okay, so as you can see, the notation as far as this form is about the same from the second derivative on up. Where if you use the slash notation, you can only use the slash notation for the first three, and then you're using numerical values after that. In most cases, very rarely will you see someone with 7 slash marks going across. They usually just use the numerical value. Okay, so this goes all the way up to the nth number derivative, whatever it is, which is the derivative of the nth minus 1 derivative. So, which would give you the nth derivative. Oh, I don't know why I put that minus 1 there. Okay. Okay, so all that nth means is that insert number. That's all it means. So it could be first, second, third, fourth, 20th, 500th, doesn't matter. All right. Okay, so if you are still writing, feel free to press pause. But we're going to move on to our next page. Oops, here we go. All right, so what if we let y equals sine of x? Okay, then that means our first derivative, so the derivative of y with respect to x, derivative of sine of x is cosine of x. Okay, what about the second derivative? Okay, that's just the derivative of our first derivative. Okay, so the derivative of cosine is negative sine. Okay, so what about our third derivative? Move that up. There we go. That's just going to be the derivative of our second derivative. Okay, so the derivative of sine is cosine, and you have to multiply that by -1, so that ends up being negative cosine. Okay, so what about our fourth derivative? That's just going to be the derivative of the third derivative. Uh-oh. Put the cubed in the wrong spot. The cubed y. There we go. Yeah. Not cube, but third power. All right, so that's going to be the derivative of negative cosine of x. Derivative of cosine is negative sine, so you have negative times negative sine, which is sine. Okay, so if we go to the fifth derivative, that's actually going to be cosine of x, which is derivative of the fourth derivative. If you use the sixth derivative, that's going to be negative sine of x, because that's the derivative of the fifth derivative. Now the seventh derivative is going to be, got to close that up, negative cosine of x. And the eighth derivative is going to equal sine of x. Okay, and it keeps going and going and going. And the reason I did 8 of them is because for sine, you'll see a pattern. You have, for the first 4, you have cosine, negative cosine, sine. Then you see that same pattern for the following 4. Cosine, negative cosine, sine. Okay, and every 4 you will have that same rotation. Cosine, negative cosine, sine. Okay, so by the time you get to the fourth derivative, you end up right back where you started. Okay, same thing with the eighth derivative. You end up right back where you started at sine. It will be the same thing for the 12th derivative, 16th derivative, any multiple of 4. So in other words, the derivative when y is equal to sine of x, any fourth derivative multiple, let's say 4k, is going to equal sine of x. Okay, now that's going to be very important coming up. Alright, so if you're still writing, feel free to press pause, but we're going to move on to our next page. Oops, there we go. Okay, what if we let y equals cosine of x? Okay, well, we have pretty much the same pattern. Well, not the same, but the same kind of rotation. Our first derivative, derivative of y with respect to x, derivative of cosine is negative sine. The second derivative is the derivative of negative sine, which is negative cosine. Our third derivative is the derivative of negative cosine, which is positive sine. Our fourth derivative is the derivative of sine, which is cosine. Okay, so you can see by the time you reach the fourth derivative, you're right back where you started at cosine. Same thing if you go for the fifth. Okay, that's going to be negative sine of x, because the pattern starts right back over again. Same thing with the sixth derivative. Oops, move that up. That would be negative cosine of x. Same thing with the seventh derivative. That will be sine of x. And the eighth derivative would be cosine of x. Okay, so the same pattern as the first four. Okay, so we know that when y is equal to cosine of x, the fourth multiple derivative, so let's say fourth multiple derivative is going to equal cosine of x. Okay, and again, that's going to be very important, and you'll see why when we start doing the examples. Alright, so if you're still writing, feel free to press pause, but we're going to go over the steps for finding nth derivatives of sine and cosine. Okay, so steps to find the nth derivative. Let's clean that up. Of sine and cosine. Okay, so your first step, you're going to divide the number of derivatives that you're asked to find by 4 and rewrite as n equals 4k plus r, where n is a positive, where k and r are positive whole numbers. And r is your remainder. Okay, so just like before, and k and r are positive whole numbers. All right, now your second step is you're going to rewrite it. Okay, so your nth derivative of, let's say, your sine of x. Well, it's, yeah, actually I'll just leave it like that. Okay, so your nth derivative, you're going to rewrite that as your fourth k derivative and your remainder. And I'll show you why I'm doing this in a second. Okay, that's because the fourth derivative of either your sine or cosine will always bring you back to the original trig function. So if you started with sine, by the time you get to the anything times 4 derivative, you'll be right back at sine. So if you started at cosine, by the time you get the anything to the fourth, any multiple of 4 derivative, you'll be right back at cosine. So you'll always be right back where you started, which means that this will give you the exact same value as your nth derivative. Would be equal to your nth derivative. Okay, and like I said, once you see in the example, it'll make perfect sense. Okay, so don't get too worried if you don't understand what I'm talking about. Okay, so we know that if your remainder equals 0, let me kind of separate that, nth derivative is equal to your starting function. Okay, so if you started with y equals sine, then your r equals 0, then it's going to be y equals sine. Okay, now if your r, your remainder, is 1, 2, or 3, your nth derivative will be the derivative of that number. Okay, and again, if these steps don't make sense to you, by the time you see the examples, it will make perfect sense, I promise. Okay, so if you're still writing, feel free to press pause, but we're going to go ahead and move on to our first example. Okay, so for example, what is the 49th derivative of f of x is equal to -4 times sine of x at the point x equals pi? All right, so remember your first step. You're going to divide your n by 4. So your 49th derivative, so your n is equal to 49. So divide n equals 49 by 4. So 49 divided by 4. 4 goes into 4 once. 4 times 1 is 4. Bring down the 9. 4 goes into 9 twice. 4 times 2 is 8. So 1. So that means that 49 is equal to 12 times 4, 4 times 12, plus 1. Okay, so you have 4 times 12 plus the remainder of 1. Okay, oops, sorry about that. Now, your second step, let me put first step here. Your second step, you're going to rewrite. Okay, now, most of the time, once you see this done once, you usually skip the second step. But I'm going to go into more detail just to explain why you can skip the second step in the future. Okay, so you have -4, or derivative of f. Well, I'll go ahead and write out the whole thing and not take shortcuts. Okay, so we know that the -4 times the 49th derivative of sine of x, we're going to rewrite that using this. Okay, so you have the -4, and I'm just going to put the -4 right on the outside there so we don't have to write it for each one. So you have the 4 times 12. Okay, so you have the 4 times 12 is 48. So you have the 48th derivative of sine of x, and you have the remainder derivative. So that's just r equals 1, so that's just the first derivative. So you have the first derivative of sine of x. Okay, which, if you notice, remember when I told you any multiple of 4 for your derivative of sine will automatically bring you right back at sine. Okay, so by the time you get done getting the 48 derivatives, this is going to be right back at sine. So you really don't need it if it brings you right back to where you started. It's that remainder that will match up with your nth derivative. So once you get here, you can cross this out and just go right to the whatever the remainder is. So if that remainder would have been 3, we would have had the third derivative here. If that remainder would have been 2, it would have been the second derivative here. But since the remainder is just 1, we only have to find the derivative of sine of x to match our 49th derivative. Okay? So that means your 49th derivative of sine of x is equal to the derivative of sine of x. Okay, so remember, it only depends on what your remainder is. Okay, and the derivative of sine of x, oh, forgot my -4. And you don't want to forget, as you can see, it's very easy to do, is your coefficient in front of it. You don't want to forget that. So -4, there we go. All right. So that means -4 times the derivative of sine is -4 times cosine of x. Okay, so that means our 49th derivative equals -4 cosine of x. And I'm just going to draw a little square around that because we still have to put in our point. Remember, it said at the point x equals pi. Okay, so when x equals pi, our 49th derivative equals -4 times cosine pi. Okay, so that gives us -4 times -1, which is 4. Okay, so at the 49th derivative, it's -4 at x equals pi. All right. So if you are still writing, feel free to press pause. But we're going to go ahead to the next example. And for the next example, we're going to kind of skip this second step. Once we figure this part out, we're just going to go right to our remainder step. All right. So let's move on to our next example. Alright, so for example, what if we wanted to find the 28th derivative of sine of x at the point x equals pi. Alright, so just like before, your first step, you're going to divide your n equals 28 by 4. Okay, so you're always going to divide it by 4. Okay, so you have 28 divided by 4. 4 goes into 28 7 times. 4 times 7 is 28. 0. Now this is where it gets interesting, because we know that 28 is equal to 7 times 4, or 4 times 7, plus 0. Okay, remember I told you we were going to skip that second step? We can kind of cross that right out and just worry about your remainder. Okay, so if you started with sine of x, you're going to end with sine of x because your remainder is 0. So you don't have to do any additional deriving. So that means the 28th derivative of sine of x is equal to sine of x. Okay, but that's only when your remainder is 0. Okay, you don't have to do anything else. Okay, so at x equals pi, sine of x, which is our 28th derivative, remember you're going to put a little circle, square around that, sine of pi. Sine of pi is going to equal 0. Alright, so if you are still writing, feel free to press pause. And we're going to go ahead and move on to our next example. Excuse me. Okay, so what is the 43rd derivative of negative sine of x at the point x equals negative pi? Alright, so first thing we do, divide our n by, actually, I'm going to stop. And what I want you to do is press pause and try to work this one out on your own. See if you got the hang of it yet. Alright, so I'm assuming you've pressed pause. So I'm going to go ahead and verify your answer. Okay, so first thing you want to do is divide n equals 43 by 4. Okay, so you have 43 divided by 4. 4 goes into 4 once. Oh, move that up some. There we go. 4 times 4, well, 4 times 1 is 4. We get 0, bring down our 3. Okay, 4 doesn't go, well, 4 doesn't go into 3, so we just put 10 there. So that's why we brought down our 3. Okay, so that means that 43 is equal to 4 times 10 plus 3. Okay, so we know already that if we did negative sine x to the 40th power, we'd end up right back here. Okay, so we can go ahead and cross this out. Well, not to the 40th power, but the 40th derivative. Sorry about that. Okay, so what does that tell us? That tells us that the 43rd derivative of negative sine of x is equal to the third derivative of sine of x, negative sine of x. Okay, so that's why I was saying that at some point you're just going to skip the second step, because once you realize 4 times anything will give you exactly where you started, it's no point in going through all of those when you know the remainder is what is going to equal. Okay, so that means we just have to find the third derivative of negative sine of x. Okay, so you have negative 1, so let's say if you're negative sine of x, so the first derivative, you just got the negative and pull it out, so that's why I have negative 1 times that, so I just pull the negative out. So negative 1 times the derivative of sine of x is equal to negative 1 times derivative of sine of x is cosine of x. Okay, so if we're looking at the second derivative, you have negative 1 times the derivative, and still negative 1 times cosine of x, that would be negative cosine of x. So that's why I just put negative 1 in cosine of x. Okay, remember this is your second derivative. Which is the derivative, this is your first derivative up here. Okay, second derivative is the derivative of your first derivative. Okay, so that's going to equal, derivative of cosine is negative sine, so you have negative 1 times negative sine of x. Okay, which is sine of x. Oh, actually, yep, that'd be sine of x. Okay, so we have our third derivative. Okay, so our third derivative, that will be, since that's still negative 1 times that, times the derivative of sine of x. That would be, oh, actually we already applied the negative 1, so we wouldn't have to need the negative 1 here, because that's positive. So excuse me for kind of jumping too far back. Okay, so we have the derivative of sine of x, which is cosine of x. There we go. Kind of mixed myself up a little bit with the negatives, but got it all back on track. Okay, so that's why we didn't need the negative 1, because that's positive now. Alright, so that means, since this is our third derivative, that means our 43rd derivative of sine of x, which we know is equal to our third derivative. Oops, straighten that out some. Of sine of x is equal to cosine of x. I'm just going to write a little square around that one. Okay, but we're looking at x equals negative pi. So at x equals negative pi, your cosine of negative pi is going to equal negative 1. Alright, so that's the 43rd derivative of negative sine of x at the point x equals negative pi. Alright, so hopefully this made sense, and I will see you on the next video.